Hello friends, let us see the indeterminate form. So in mathematics, particularly in calculus, an indeterminate form is an expression whose limit cannot be determined directly from the individual limits of its components, like limit x tends to 2, x minus 2 divided by x square minus 4. So you cannot find directly by plug in the value x tends to 2. Okay, but that means it doesn't mean that limit does not exist, but rather than further analysis, means we need some further analysis. Either we have to factorize or we need to do something else. Okay, in this case we can factorize and cancel out the term. We can find out the limit. So such kind of forms are known as indeterminate form whose value is not deterministic, like 3 by 6. Its value is deterministic, like its value is 0.5. Okay, but there are certain forms whose value not deterministic. Those forms are known as indeterminate forms. So these are the indeterminate forms: 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 raised to 0, infinity raised to 0, 1 raised to infinity. So these are all indeterminate form. Whose values are, we can say that differently. Okay, like if I write the limit x tends to 0, x by x, we know its value is 1. Okay, but if I write limit x tends to 0, x square by x, then its value is 0. If I write limit x tends to 0, x by x square, then we know it's not exists because it tends to infinity. So these are all indeterminate forms. Now, if we come across this kind of indeterminate form, then there is one theorem, and that theorem helps us to evaluate the limits. And that theorem is known as L'Hopital rule. So this is the theorem. This theorem is like this, that suppose limit x tends to a fx by gx is 0 by 0 or infinity by infinity. It is either 0 by 0 or infinity by infinity. Then the theorem says simple like this: limit x tends to a fx by gx. So either we are in 0 by 0 form or infinity by infinity form. Then it says like this: limit x tends to a fx by gx is equal to limit x tends to a f derivative at x divided by g derivative x. So derivative of f divided by derivative of g. If this limit exists, then you can say that the limit exists. So individually, you take the derivative of numerator and the derivative of denominator. If we have other form, either like 0 by g instead of 0 by 0, if you have the form like 0 into infinity or infinity minus infinity or 1 raised to infinity kind of things, then you can convert this form into either 0 by 0 or infinity by infinity, and then can use the result. Okay, so this result is simple result, and we can use this result to solve the example. So let us we solve some example. So let us begin some example. Evaluate limit x tends to 0 limit x tends to 0 e to the power x minus 1 minus x divided by x square. So here you see the limit x tends to 0 e to the power x minus 1 minus x by x square. Now see, when x tends to 0, e power 0, that is 1, tends to 1. So this is 1 minus 1, 0, minus 0. So this is 0. And denominator is also 0. So that is 0 by 0 form. And so now we can apply the result. Because it is 0 by 0 form, you write e power x. Derivative of e power x is e power x. Derivative of 1 is 0. Derivative of x is 1. And derivative of x square is 2x. And we again check the form. So this we did, limit x tends to a fx by gx is equal to limit x tends to a f plus x by g dash x. If that limit exists, then it is the answer. If not, then if we may have another round of the result to be used. So e x tends to 0, so e power 0, so that is 1 minus 1, so this is 0, and here x is there, so again it is 0 by 0 form. Now this is equal to limit x tends to 0. Again the derivative of e power x is e power x, and derivative of 2x is 2. And now when x tends to 0, e power 0 is this is 1 and 2. So this is your answer. Okay. Take another example. Evaluate limit x tends to 0 e power x plus e power minus x minus x square minus 2 divided by sine square x minus x square. Okay. So we have to evaluate limit x tends to 0 e to the power x plus e to the power minus x minus x square minus 2 divided by sine square x minus x square. Now here see x tends to 0, e power 0, that is 1. So this is 1 plus 1, 2. This is 0 and this is 2. So 2 minus 2 is 0. And we know as x tends to 0, sine also 0 and x square. So this is 0 by 0 form. So now we need to use the result. So we are using the result. Derivative of e power x is e power x. Derivative of e power minus x is e power minus x. And then the derivative of minus x, chain rule we need to apply, is minus 1. So this is minus e power minus x. Derivative of x square is 2x. Derivative of 2 is 0. Now derivative of sine square x. So this is the function of something square. So its derivative is 2 sine x. But then we need to take the derivative of again sine x, and that is nothing but cosine x. And we know the trigonometric formula 2 sine x cosine x is nothing but sine 2x. So here the derivative of sine square x is sine 2x. Derivative of x square is 2x. Now again we check x tends to 0. So this is 1. This is 1. So 1 minus 1 is 0. X is also there. So this is 0. Sine 0, 0, 2x. So this is again 0 by 0 form. So this is equal to limit x tends to 0. Derivative of e power x. E power x, derivative of e power minus x is minus e power minus x. So this will be plus e power minus x. Derivative of 2x, so that is 2. Derivative of sine 2x, so derivative of sine is cosine 2x. And derivative of 2x is 2 and minus 2. So again we check, this is 1, this is 1, 2 minus 2. So this is 0, this is 2. Cosine 0 is 1. So this is 2 and minus 2. So that is also 0. So we have again 0 by 0 form. So let us take the derivative. Derivative of e power x is e power x. Derivative of e power minus x is minus e power minus x. Derivative of cosine is minus sine 2x and again 2. So this will be minus 4 sine 2x. And x tends to 0. So this is 1 and minus 1. So this is 0 sine. So this is again 0 by 0 form. So then limit x tends to 0. Derivative of e power x is e power x. Derivative of e power minus x is minus e power minus x. So this is plus e power minus x. Derivative of sine, so that is cosine 2x and again 2. So minus 8 cosine 2x. And now when x tends to 0, this is 1, 1 minus 8. Cosine 0 is 1. So this is a minus 1 by 4. So that is the answer. Okay. Let us take one more example. Evaluate limit x tends to 1, x minus x to the power x over 1 plus log x minus x. So here we have limit x tends to 1, x minus x power x over 1 plus log x minus x. Now x tends to 1, so this is 1, this is 1 power 1, so this is 1. So 1 minus 1 is 0. Log 1, log 1 is 0. So this is 0, this is 1, this is 1, 1 minus 1. So that is also 0. So that is 0 by 0 form. So now we have to use the result. So limit x tends to 1, derivative of x is 1 minus. Now you know derivative of x power x is nothing but x power x into 1 plus log x. Okay, you can use this result. You can try to find out the derivative of x power x, even 12th standard also you did. So this is a x power x into 1 plus log x. Derivative of 1 is 0. Log x 1 by x. Derivative of x is 1. So now we again check x tends to 1. So this is 1. This is 1 plus 0. So and 1. So this is 1 minus 1, 0. This is also 1 minus 1. So 0. So again we have 0 by 0 form. So this is equal to limit x tends to 1. Now derivative of 1 is 0. So this is minus. Now this is product rule we need to apply. So let us take the derivative of x power x and keep 1 plus log x as it is. So derivative of x power x is x power x into 1 plus log x. Already 1 plus log x is there. So this is 1 plus log x square. Then plus, but already minus sign is there. So let us use minus. Keep x power x as it is. And derivative of 1 plus log x is 1 by x. Derivative of 1 by x, we know that is minus 1 by x square. So this is minus 1 by x square. And now x tends to 1. So numerator is x tends to 1. So this is negative 1 x power x. So 1 plus log 1. So that is 1 plus 0. So this value is 1. This value is also 1 because x tends to 1. 1 power 1, 1 upon 1. So 1. And this value is also 1. So 1. So this is minus 2 by minus 1. And so the answer is 2. We can see in another video some more examples.